Hi guys. Once again, we are back with a new video that is, this is going to be based on differentiation using first principles. So here, what we are going to the overview is like we are going to quickly see what first principles are and like how to differentiate using first principles, and then we will be solving 5 questions and yeah, that is how it's going to be, right? So first, straight away, let's get into the lesson, right. So simply, now let's assume we need to find the differentiation, right? We need to find the differentiation of the point. Let's assume x. I need to find the differentiation of let's assume I need to find the differentiation of this y or else the fx, right? So we know this, right? It's going to be fx. I need to find the differentiation of this fx with respect to x, right? So what we are going to see is how to do this using the first principles, right? Okay, so what do we need to do? We need to find the differentiation of y or else the fx in with respect to x. So first of all, what you need to understand is, right, differentiation means, right, what differentiation means. So differentiation is the slope, right, the slope or else the gradient of a certain given point. This is the basic idea, not the definition. This is the basic point. So if we need to find the differentiation at this point, right, this corresponding coordinate fx x, right, if I need to find the differentiation at this point fx x, then what do I have to do? I have to find the gradient drawn to that point. And I need to find the gradient drawn to that point, right? So that gradient is called as dy over dx, right? Dy over dx, right? Increasing rate of y. Fine. So this is basically what differentiation is: the slope or else the gradient of a certain given point, right? Okay, so fine. Now let us see how to do that. How to find the gradient of this point corresponding to these coordinates y, x, right? Okay, how to find the differentiation, right? Fine, using the first principle, right? Fine. Let's see, right? Let's see that. Fine. Okay. Right. So now let us find it. So to find the gradient, right? Usually we know we need 2 points. Just having 1 point in a graph, we are unable to find a gradient. That is how we know from the basics that we have learned in our previous classes, right? Okay, so for finding this, what I would do is, right, simply I'm going to give a small increment to the x value, a small increment delta x to the x value. So what will be the new x value? The new x value will be x plus delta x. So when the new x value is x plus delta x, what will be the new y value? What will be the new y value? How to find that? If you go along this curve, right? So it will be, so to this fx curve, in place of x, if you substitute x plus delta x, you're going to get the new y value. It is going to be fx plus delta x, right? Okay, now I have two points, right? I can simply find the gradient. How will I find the gradient? Gradient can be found how? Exactly this over this, right? That is going to be the gradient. Okay, so the line joining those 2 points is this. Fine. So I will find the gradient. So what is it going to be? What is this going to be? This is going to be f x plus delta x minus fx. From the upper limit, you have to subtract the lower limit fx from the x plus delta x. You have to okay, so that's pretty straightforward. You know, okay, this is delta x. Now gradient can be written simply, or actually, f x plus delta x minus fx over delta x, right? Over delta x, this over this. That is how we write gradients, right? So we know tan theta, right? Okay, so what I need is not this gradient. What I need is not this gradient. I need the gradient at this point. So to do that, actually, there's a nice way. That is, we're going to use limits, right? So we are going to use limits. Limits, when delta x goes to 0, let's see what happens to this. When delta x goes to 0, let us see what happens. Now you can see, right? When delta x decreases, when delta x decreases to this much, from here to here, this much, the new y value is this much. Now, sorry, it's not that, it's this, right? So new delta y value is this much, right? So now the gradient is going how exactly? It's going to go in this way. So further, if you decrease delta x, right, it's going to be this much, right? So if you keep on decreasing delta x, can you figure this out? It's going to exactly going to go on this point, right? I will clearly show that, right? Right. Right. I will clearly show that. So it's going to be simply when delta x decreases and keeps on decreasing, it's going to be, right, it's going to be falling on this point, right? It's like we are going to have the gradient as this. When delta x keeps on decreasing, it's going to concentrate to this point, and we're going to get the gradient, or else the tangent to that point. So once we get the tangent to that point, that is simply the differentiation. We call that as the differentiation, or dy over dx, or f dash x, f dash x. So this is how we find the differentiation, or f dash x, the first derivative, using first principles, right? So what is this actually? This is delta y over, so this is what? Delta y over delta x, right? So we can further write this as what? We can further write this as delta y over delta x, right, is equal to what? F x plus delta x minus fx divided by delta x, right? When what? This is going to be dx, dy over dx, or the differentiation. This is going to be dy over dx, or the differentiation, when the delta x goes to 0. So we have to apply limits to both the side, right? Okay, when limits dx goes to 0, limits dx delta x goes to 0. So if you can show a certain expression as the delta y of it over delta x of it, when the limit goes to 0 in this format, so it's simply like you have found the differentiation, right? So fine, we will go for some examples and see, right? I will use this as the examples. So for the first example that we are going to see is fx is equal to x squared. Now you are given a graph of, right? You are given a graph of what? Fx is equal to x squared, right? You need to find the gradient of that graph simply, right? So sorry, the differentiation of that graph, that is the slope, right? Okay, so this is how you do it. You just give a small increment of delta x, right? You have to give a small increment of delta x. So what happens is, when you give a small increment of delta x, so the y is going to be, or y is also going to be incremented, as well as what? X is also going to be incremented, x plus delta x, x plus delta x, right? Okay, so this is the first expression. See the second expression. What we are going to do is, we need what? We need to show get an expression as this fx plus delta x minus fx, right? So to that, of course, what I'm going to do is from the second expression, I'm going to subtract the first expression, right? So simply fx plus delta x minus fx, when we subtract second by one, it's going to be x plus delta x, this is squared, squared minus x squared, right? So I'm going to see what this is, right? Let's expand and see. Fx plus delta x minus fx is going to be what? X squared plus 2x delta x plus delta x squared minus x squared. I just expanded this term, right? So you just have to expand that. It's a perfect square, right? So once you expand, you will see this is going to get cancelled. This to this. What remains is, right? What remains is this 2x delta x plus delta x squared, right? That is fx plus delta x minus fx. So what you can do next is you need to make this expression, right? You need to make this expression. You need to make this expression delta x, this completely over delta x, right? So for that, what I do is I divide both the side by delta x. I divide both the sides by delta x. So fx plus delta x minus fx over delta x is going to be what? This two, this cancels, to this square cancels, right? So what is going to remain? 2x plus delta x, right? So next, what you can do is, right? Next, this delta x should go to 0. This delta x would, okay, I have is to write that, right? This should go to 0, right? So in this also, let us do that, right? Okay, limits delta x goes to 0. For both the sides, limit delta x goes to 0, right? Fine, this is what? This is the dy over dx, the differentiation, the first derivative, right? So when delta x goes to 0, this goes to 0 when delta x goes to 0, right? So what remains is 2x. So this is going to be the answer for the first problem. This is going to be the answer for the first problem. Let's move on to the second problem. The first problem is done. So let's move on to the second problem, that is fx is equal to what? X cube, right? The second problem is fx is equal to x cube. Let's quickly do this, right? So I will give a small increment fx plus delta x. So you have to give the increment to x also, x plus delta x cube. This is the first expression. This is the second expression, right? So you need to subtract second expression minus first expression. So it is going to be fx plus delta x, fx plus delta x minus fx is equal to x plus delta x cube minus x cube, right? So what is this going to be? Fx plus delta x minus fx is equal to, you have to expand this x cube plus 3 delta x squared x plus 3 delta x squared, right? Plus delta x cube minus x squared, right? So if you see these two, this cancels out. So yeah, that to that cancels out. So what remains is, right? What remains is 3 delta x squared x plus 3 delta x into x squared delta x cube. So what we can do is we can simply apply limits. Delta x goes to 0, fx plus delta x minus fx, divide both sides by delta x, right? Divide both sides by delta x, and limits, we will apply limits also, right? So since I do not have space on that side, I'll apply this side, right? So what happens is first of all, this to this to this to this. So what remains is dy over dx is equal to 3 delta x into x plus 3x squared plus delta x squared. So when limit delta x goes to 0, what happens? When delta x goes to 0, since there is a delta x on this term, it's going to go to 0. This is also going to go to 0. So dy over dx is simply going to be what? 3x squared. This is going to be the answer, right? So that's the answer for x cube. So when we differentiate x cube, it is going to be 3x squared. Fine. Let us move on to the next problem. That is third one, right? Third one. So the third problem is simply what? It says 3x squared minus 2x. 3x squared minus 2x. It's fx is equal to 3x squared minus 2x, right? So here also, let's give a small increment fx plus delta x. Let us give the same increment to all the x terms, right? Minus 2x plus delta x. So this is the first expression, this is the second expression, right? So 2 minus 1, what is it going to be? It's simply going to be, I will simplify only the right hand side, right? 3 x squared plus 2 x delta x plus delta x squared minus 2x minus 2 delta x, right? And then whole thing minus, right? Whole thing minus 3x squared. So from where did I get this 3x squared? From this part, right? So this part, like 2 minus 1, right? 2 minus 1. So I have to, from this complete second expression, I have to subtract this part also, right? I will subtract that 3x squared minus 2x, right? So if I subtract that, this is going to be 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x minus 3x squared plus 2x. So let's cancel the terms that is being getting cancelled, right? So 3x squared to 3x squared is going to get cancelled. So simply what we have to do next, we have to divide both the sides with what is fx plus delta x minus fx. So we have to divide by what? Delta x. So the remaining things, right? So the remaining things we need to subtract, divide by delta x. Fine. Let us divide it by delta x. So when I divide them by delta x, what happens is this delta x to this delta x cancels out. One delta x here cancels out. This cancels out. So what remains is 6x is going to remain. From this 6x is going to remain. From here, what is going to remain is 3 delta x is going to remain. And then here from there, of course, minus 2 is going to remain, right? So now, as usual, what is in this side is fx plus delta x minus fx, right, over delta x. You need to do what? Next, you need to apply limits. Delta x goes to 0. Fx plus delta x minus fx over delta x is equal to limits delta x goes to 0, 6x plus 3 delta x minus 2, right? So if you see this, who goes to 0? This term goes to 0, right? That term goes to 0 because of the presence of delta x. So simply this is what the thing in the left hand side is. It is the derivation, first derivative, dy over dx. So this is going to be what? Answer is 6x minus 2, right? 6x minus 2. So that's also done. We did the second one. Third, I'm not going to do the fourth one because it's also the same kind of the third problem, right? So, but the fifth one is somewhat of tricky. So let us try this fifth one. Y is equal to 1 over x squared, right? Y is equal to 1 over x squared. Fifth problem, y is equal to 1 over x squared, right? So simply we have to give a increment, right? So increment. So I will show this somewhat in a different way and in easy way, right? So when you give a small increment to x, what happens? X plus delta x, right? So then similarly, y also increments by delta y. Y also increments by delta y. This is a easy method, right? So I mean, easy means the same way, but the thing is like you have to write less, right? So okay, take y to the other side. So delta y is equal to 1 x plus delta x squared minus delta y, right? Sorry, not delta y, right? What you take is y to that side, right? Okay, so now simply delta y is equal to 1 over, you have to write x plus delta x whole thing squared. What is y? Y is 1 over x squared. So you can write it as 1 over x squared, right? So delta y you can simplify. I will take the LCM x squared minus x plus delta x whole thing squared divide by x squared x plus delta x whole thing squared, right? So in that case, delta y is equal to x squared minus, we will expand this term, right? So if we expand the of x squared, it's going to be x squared plus 2 delta x into x plus delta x squared divided by, below also let's expand x squared plus 2 delta x into x plus delta x squared, right? So delta y is equal to what? X squared minus 2 delta x minus delta x squared divided by x into x is x squared into x squared is x to the power 4 minus 2x cubed delta x plus x squared delta x squared. So what you can do is you can divide both the, like from this, can you see even like this same thing is this, right? Delta y over delta x. What is this? If like, delta y over delta x is this, right? Fx plus delta x minus fx over delta x. Fx minus fx plus x, fx plus delta x minus fx over delta x. That is the same thing, delta y over delta x. So delta y over delta x is also dy over dx. So if you can show it as delta y over delta x, it is dy over dx when limit goes to 0, right? So I will divide all the terms by delta x. Okay, delta x, sorry, this cancels out, right? First of all, let's cancel them. These two, this cancels, right? Let's not write this now itself, right? Let's write another step, delta y. So yes, delta y is equal to minus 2 delta x squared minus 2x cubed delta x plus x squared delta x squared. So we will divide all by delta x. This also delta x, this also delta x. So what happens? This to this cancels, right? So 1 delta x to this delta x cancels, right? Let us apply limits also, right? Limits delta x goes to 0. This thing limits delta x goes to 0, right? So what happens is simply, this is what the thing on the right left hand side is dy over dx, right? It is simply dy over dx. Now what you get on the right is minus 2 minus delta x, right? Minus 2x, right? So there should be an x. We have forgotten that x. This x, right? We have forgotten to write that x. It's there, right? X there, x is there. So that x is here, right? So that x is here also. Fine. So in that case, this is going to what? X to the power. So it's x to the power 4, right? Power 4 minus 2x to the power 3 delta x plus x squared delta x squared, right? So limit delta x goes to 0. So what are the terms that is going to be to 0? This, and this. So what is remaining is dy over dx is minus 2x over x to the power 4. So 1x, 2x cancels. So the answer is going to be minus 2 over x to the power 3. This will be the answer, right? So this is not going to be very difficult, guys, right? You can either use the first method that I showed you or else the second method. Either way, it's the same thing. If you understood the principle properly, right? So delta y over delta x is fx plus delta x minus fx divided by delta x. If you understood this properly, you would figure this out pretty easily.